Section 8.2, equations in the three-dimensional space. In this section, we'll try to build equations of lines, line segments, and planes. Let's begin with lines. P0 is a point in R3, and V, having three components A, B, C, is a vector. Then the line through P0 parallel to V is defined as in this equation. And we can make a line, draw a line in this way. Here P0 is this one, and then V is a vector. So from this one, now the line can be made including P0 in the direction of V by using this equation. R is a point on the line, so we can write R in this way, x, y, z. Then this equation can be written in this way. That is called the parametric equation. This came from the first component, from second component, and from the last one we have that one. Now this parametric equation can be written as the symmetric equation, assuming A, B, and C are non-zero. We can solve each of these equations for t. Okay, so from the first one, t equal, now moving this one to the other side, divided by a, so x minus x0 over a. From this second one, now t equal, and y minus y0 over b. From the last one, we have t equals z minus z0 over c. So for the same t, we can put them equal to get this symmetric equation. Once we are dealing with part of a line, and from P to Q, then that is a line segment. The line segment, the equation for the line segment can be defined in this way. R of t is 1 minus t OP, the vector here, and t OQ. And you can easily check that once t is 0, so t must be restricted into this interval. If t is 0, then there must be a vector p, and once t is 1, then it is 0, and then just OQ, the vector here, so that R of t, defined in this way, with t moving from 0 to 1, will make this line segment. Okay? Find a vector equation and parametric equation for the line that passes through the point 5, 1, 3 and parallel to the vector 1, 4, minus 2. The vector equation can be written in this way. R, we are using exactly this equation, and then here now we can find the parametric equation in this way. Okay, all. Okay, now we try to write down, rather than P0, and we write down here the numbers 5, 1, 3, and then that is t times 1, 4, minus 2. This is the vector equation. And if we write down by using the parameter t and the components, then that is parametric equation. So R is now can be written as xyz, so that from here, now x equal, the first component is 5 plus t, and y equal 1 plus 4t, and z, the final one, is same as 3 minus 2t. Right? That is the parametric equation. Find the parametric equation of the line segment from this point to that one. R of t, by using the formula here, 1 minus t of the first point to 4 minus 3, and plus t, and that is beginning point, and this is a terminal point. It's a 3 minus 1 and 1. Okay, so we try to rearrange it. Okay, so that is now here for the first one, twice of 1 minus t, so that 2 minus 2t plus 3. Okay, let's try to write it in this way. 2 minus 2t and plus 3t, right? Okay, now that one is now 4 minus 4t and minus t. This one is minus 3 plus 3t and plus t. Here you can simplify 2. Okay, that is plus t. The second one, that is 4 minus 5t. The last one, minus 3 plus 4t. So it's a parametric equation. It's now, that's r of t is xyz, so that you write down here x equal this one, y equal this mid component, and z equal the last component. But then that's the answer, right? And of course, t must be between 0 and 1, right? Always line segment is along with t is between 0 and 1. Okay. Now we'll try to build equations of planes. X0 is a point on the plane. So x0, y0, z0, and n is a normal vector to the plane. Then we can get the equation in this way. Geometrically, we can explain in this way. Okay, not this one. Here, let's draw a plane. Plane is given in this way. Now, the point x0 is here. Then we choose an arbitrary point in the plane. Then that is x. And normal vector is given here now. Then, if we draw a vector from x0 to x, then because n is normal vector, that must be orthogonal. So by using the dot product, we have n, now x minus x0 must be 0. That is exactly this one. And n is ABC. It doesn't have to be normal, the unit vector. Any normal vector will be fine. And here, ABC and x minus 0 has these 3 components, so that the dot product will make that and equals 0. So the plane, the equation of plane can be obtained in this way. Find an equation of the plane that passes through the points, 3 points. So in this problem, rather than a point and normal vector, these two are major components, major ingredients for planes. So rather than a point and normal vector, now 3 points are given. So we can use one of them for the point, but we have to find the normal vector. How? Okay, 3 points are given. So let's try to visualize 3 points. So that is P, that is Q, that is now R, 3 points on the plane. We have to find the plane is including these 3 points. Now we have to find the normal vector, and to find this one, we may think in this way. Okay, we think PQ, the vector, and PR, another vector. Then if we try to get cross product, then we can get a normal vector, right? So that we may get N to be PR. Okay, let's try to use PQ first. PQ, the vector, PQ, and now PR. Then it'll be a normal vector, right? Okay, what is PQ? That is Q minus P. So that is 2, subtraction, 2, 0, 1, 2, 0, 1. Now cross product with PR, R minus P, which is 0 and 3, right? 3 and minus 1. Okay. Now how can we get this one? By using the formula, the determinant of the matrix I, J, K. The first vector is 2, 0, 1. The second one is 0, 3, minus 1. Right? So that is, now for the first one, for I, we have determinant of the corresponding minor, which is 0, minus 3. Right? For J, the minor is this 4, 2, 0, 1, minus 1. And that is, determinant is minus 2, 0. So that minus 2, but for J we need minus, so that 2. For the last one, the corresponding minor is this, so that must be 6. Okay, so we found a normal vector, and remainder part is quite easy. And here you may use P as a point, so that we can write in this way. The equation must be N dot X minus P. Like that, that is 0. So you can expand, then that will be the final answer. Okay, that's the end of section. Thank you.